Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to continue parts 3 and 4 of the Regents Exam of Algebra 1 for June of 2023. Part 3 is 4 problems, and part 4 is only 1 problem. So the 4 problems here, each one of them receives 4 credits, meaning twice as much as the previous part. In problem number 33, it tells you graph two graphs, f of x equals absolute value of x plus 1, and g of x is negative x squared plus 6x plus 1. You should know that, well, you have your calculator, you can plot them, but you should know that the absolute value of x is basically a V-shaped graph that has its vertex at the origin and it's going up, right, and left. But since we have plus 1, meaning I'm moving up 1 unit. So basically, you can create a table, by the way. But when you do it, you will get this point. And then if we number these lines like, okay, we can use some color or ink, 1, 2, 3, 4, 5, for example, negative 1, negative 2, negative 3, negative 4, negative 5, and then 1, 2, 3, 4, 5 for the y, and negative 1, negative 2, negative 3, negative 4, negative 5, and then we may continue if we need. Okay, so I have, this is the point, and the absolute value of x, and it's not multiplied by anything. So the slope is either 1 or negative 1. So I can pick few points here and few points there and draw the V shape, and that would be the absolute value of x plus 1. The plus 1 here tells you that we go up 1 unit in the y direction. Well, so this is one branch, and this is the second one. For the second equation, negative x squared, so that's a parabola opening down because of the negative sign. Its y-intercept is 1, meaning if x is 0, I get the same point. If you know the axis of symmetry is basically you divide b over twice a. Negative b over twice a. So negative 6 over 2 times negative 1 equal positive 3. So positive 3 here is an axis of symmetry. I'm going to draw just a dashed line. Again, you can draw it, you can plot it with a calculator and look at the table for the points, and that's the basically the safest way to do it. But here, what we are saying is, I get this point. 3 is the axis of symmetry, so I want to teach you something. The axis of symmetry, meaning it's the right-hand side is the mirror image of the left-hand side. So if I have a point here that is 3 units to the left of the axis of symmetry, there must exist another one 3 units to the right of the axis of symmetry. So if I have 0 and 1, I would have 6 and 1. Okay, how about if x equals 1, for example? If x equals 1, you get negative 1 plus 1, they cancel each other, and 6 times 1 is 6. So at 1, I would have a point here. Again, this point is 2 units to the left, so I must have 2 units to the right. Oh my God, I already found the 2 points of intersection just by coincidence. When I do x equals 2, I get negative 4 plus 12 is 8, plus 1 is 9. So at 2, I have 9. So 1 to the left, I have 9 also. And, well, if x is negative 1, I get negative 1 plus 6 is 5 plus 1 is 6. Do we have No, we did 1. I'm sorry. So at -1, you get -1 minus 6 is -7 plus 1 is -6. So at -1, I have -6. It means this is 4 units. So if I go 4 units, I have this point, and I have something that looks like that. Oops, no, I need to carefully. So I have this point. No, yeah, we have this point, and we go up. Uh-oh, I keep looking at the wrong point. Okay, so we go up to this point, and then we go back down to -6. So it goes to this point, something like that. So you get a parabola and a V shape, and the points of intersections are this point and that point. Based on your graph, determine all the values of x for which f of x equal g of x, meaning the points of intersection. So you can write x equals, the points are x, x equals 0, because if you say f of 0 equals 0 plus 1, g of 0 is 0 plus 0 plus 1. So you get 1. And then at x equals 5, this would be 5 plus 1 is 6. This would be -25 plus 30, that's 5, plus 1, that's 6. So 1 and 5. This is the first point, or these are the 2 points. Now, we move to the next second problem. It says, Jean recorded temperatures over a 24-hour period, one day in August in Syracuse, New York. Her results are shown in the table. So they give you the time as well as the temperatures, and these are the points. So state the entire interval over which the temperature is increasing. Increasing temperature meaning going up. I see this part is going down, this branch is going up, and then down again. It never goes up back. So the interval x, you can write it in any form. So you can say x greater than or equal to 6, less than or equal to 12. Okay. State the 3-hour interval that has the greatest rate of change in temperature. The rate of change is the rate of change in the y with respect to x. What do we call that? The slope. Yes. It can be positive or negative. So I see here that I'm dropping from 80 to 75 in 3 hours. So I drop 5. Here, I drop another 5. Here, I go up 2, 4, 6, 8. So this is better. In the next 3 hours, I go 2, 4, 6, 8, 10, 12, 14. Oh, that's the highest. And you can see that this slope is 0. That's 1, that's 2, whatever. So as you turn counterclockwise, if it's positive, the slope or the rate of change increases. And you can see that this line is more, you turn more than that. So now it's from 9 to 12. And you don't see any drop more than that. You see, you go from this temperature to that temperature, that increase. Here you decrease a little bit, you decrease a little bit, you decrease a little bit. In fact, during these 9 hours, you don't make that difference. So definitely here, the 3-hour interval that has the greatest rate of change is from 9 to 12. So 9 a.m. to noon. State the average rate of change from hour 12 to hour 24. So I know that average rate of change between 12 and 24 equals the temperature at 24 minus the temperature at 12, 24 minus 12, because you go from 12 to 24, from first to last, divided by 24 minus 12, equals. At 24, if this is 70 and it goes up by 2, so that's 74. Minus. At 12, it's 92 over 24 minus 12. This is negative 18 over 12 equals negative 3/2 or negative 1.5 degrees Fahrenheit per hour. Explain what this means in the context of the problem. You have many ways to say it. You can say, for example, if the temperature drops 1.5 degrees Fahrenheit per hour, if it was dropping like constantly, 1.5 degree every hour, it will reach 74 degrees Fahrenheit in 12 hours. Or you can say it means it drops 1.5 degrees Fahrenheit per hour. If you want to think about it, if I drop 1.5, is like, this would be like a straight line. But of course, temperature doesn't change like that. But we are saying if the temperature would drop 1.5 degrees Fahrenheit every hour, I would go from 94 or from 92 to 74 in the same amount of time. So this thing and that thing will start at the same point and at the same point. And that's the meaning of the word average rate of change. Average meaning it's constantly dropping at the same slope, okay? And that's basically is the slope of the line, negative 3/2. So it's the same meaning. If you go to the third problem, okay, the third problem tells you solve the following system of inequalities graphically on the set of axes below. Okay, so what you know is that we have to write this in the terms of y is greater than or less than mx plus b. Well, sometimes there is an easier way to do it, but since you have to show work, you will create a table for, say, 2x plus 3y equals 0, and you say x and y. And you can say, for example, the easiest way that I will show you, and then I will drop the, or I will draw the table, is to say the following. If you have the system written in this form, like the variables on the left-hand side and the constant on the right-hand side, just divide the right-hand side by the coefficient of x. Negative 6 divided by 2 is negative 3. So negative 3 is the x-intercept. See how easy it is? Negative 6 divided by 3 is negative 2. So the y-intercept is negative 2. I already found the line. It's greater than or equal. So it's a solid line. Okay. And so for every 2, you go 3. Every 2, you go 3. And this line, it's a solid line because greater than or equal. So here. Okay. Now, when you rewrite this, you can subtract 2x from both sides. So you get 3y is greater than or equal to negative 2x minus 6. And then you divide by 3 both sides. I get y is greater than or equal to negative 2/3 x minus 2. So you see the minus 2 is the y-intercept. The slope is negative 2/3. So every time I move 3 units to the right, I drop 2 down. 3 to the right, drop 2 down. And that's why I told you it's the easiest way to do that. And that's the first line. And sure enough, y is greater than that. So the feasible, we call it the feasible area, if you want, region, if you want to know another vocabulary word that may help you later in other courses. So this is the region that we are talking about for the first inequality. Okay, when we go to the second inequality, it says, notice now the x and y are not on the same direction, but I could have said this, write this as negative x plus 3y, meaning I'm going to move these and I move that to the other side, would be greater than negative 6. Very similar to this one, but it's negative x. Notice here, if I do it this way, and I divide the negative 6 by the negative 1, I get x equals 6. So we haven't numbered those. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So x equals 6 is a point of intersection. And if I divide negative 6 by 3, I get negative 2. So negative 2 is another point of intersection. But this line is dotted, right? Dotted line. Oops. Yeah. And again, 3y or y is greater than that. If you would write this in the same way you want to write it as y is greater than, so I would divide by 3. So I get y plus 2 is greater than or equal to x over 3, right? And then I'm going to subtract 2 from both sides. So I get y is greater than x thirds minus 2. Negative 2 is the point of the y-intercept again, like we said. And then the slope is 1/3. So every time you move 3 to the right, you go 1 up, 3 to the right, 1 up, and so on and so forth. So you can see that's a very easy way to draw. Y is greater than that. So this is the region satisfied by the second inequality. So really the feasible region is between these two lines and above them, but not on this line. This is greater than. So if I have a point here, it's not in the region. The region is just slightly above this line. So it's basically, if you want to color it so you can see it, it's this region. I go just from this line and go like that. So you can see. So I go from, from the dotted line up until I come here. And of course, you can extend this just to show the region. Okay. Is the point 4 and negative 2 in the solution set? So if I go to 4 and negative 2, I come here. And this doesn't satisfy the second constraint. No. and then explain your answer. This point, I can say this point only satisfies the first inequality. But not the second. That would be enough. As I said, I could go and draw these. Well, I did the apps and got the inequalities here. So I want this to be greater than or equal, which is this one. Oops, I'm sorry. I have to say alpha greater than or equal, right? Or you can say enter several times here until you get it. It's the same thing. And I'm going to say y is greater than negative 2/3 x minus 2. I'm going to go to the next one, click alpha greater than, and this would be x over 3 minus 2. I can go to the window, minimum x, I can say, for example, whatever, -5 to 6, and then the y minimum, say -3, say to 6 again, something like that. And it will draw this first constraint and then the second one. And you can see this region right there. If you go to the table and take 4, because I told you is 4 and -2 in the solution set. If you go to 4, you say 4 and -2/3, this point, which is above the -2. So the -2 is not in the region, right? Okay. So, you see, again, 4 satisfies the first constraint, because the first constraint, which is the solid line, this point is at -4.667. So it satisfies the 4 and -2. But for the second line, this point is 4 and -2/3, which is higher than -2, so it doesn't satisfy. So you can also use the calculator to solve this problem quicker. Okay, because you can find you say -6 and 0, it gives you I'm sorry. No, yeah, 6 and 0 for the second constraint. And if you go to the x equals 0, it gives you that the y-intercept is -2 for both. That's what we have. So you can use the table to construct the inequalities much quicker. I just wanted to show you that, generally speaking, if you write the equation in this form, if it was an equation, not an inequality, and you want to plot this line, you don't necessarily have to write it as y equals mx plus b. If you have it in this form, which is a standard form, you have the x and the y on the left and the constant on the right, dividing the right-hand side by the coefficients gives you the x-intercept and the y-intercept, usually quicker, because you don't have to separate the y and whatever. But if you are going to plot it, you have to get it in terms of y equals a function of x. Okay. Susanna collected information about a group of ponies and horses. She made a table showing the height measured in hands, HH, and the weight measured in pounds of each pony and horse. Write a linear regression equation for this set of data and round all the values to the nearest hundredth. So I will go to stat and make, say, the first equation x, which is the height. So I entered 11, 12, 13, 14, 15, 16, and 17. And as I always say, the only error that can happen in these types of problems is that you enter the numbers incorrectly. Make sure that you look at the numbers after you enter them, because sometimes I click, say, the 6 and it doesn't show up. And I, instead of say 42, I enter 4, or instead of 28, I enter 8. So the numbers, of course, will be incorrect. But here I can see 11 through 17. These are easy. These are 3 digits, 2, 6, 4. So if you see like 3s and then one of them is a 2, you know that you entered you have a wrong entry. 700, 850, 1000, 1230, 1495. And I'm done. So I go back, select stat again, and go to calc and see linear regression ax plus b, which is 4. So I can enter 4 and it gives me the values right there. So I want them, so I would say y equals 184.89, because they want it to the nearest hundredth, times x minus 1706.07. So that's the weight, that's the height, and that's how you estimate the weight from the height. Okay, state the correlation coefficient. Usually if I think I have to go to catalog. Oh my God. And you go to diagnostics, I think. Can I go to the D quickly by clicking? Oh, diagnostics off. I make it on. I think that should do it. So if I go to stat again and use 4. No, I didn't get it. So, okay, if you might know how to do it. I never use the calculators for these, but I think the other way you do it is you go to stat and test. And maybe if I go linear regression t-test, I don't need that, but it will give you, yeah, x is in L1, x2. I don't care about the rest. You just go to calculate. And here, definitely, it has to give you the R. R is 0.9. So the correlation coefficient R equals do they want it? Oh, nearest 100. So 0.99, because that's 985. Okay, so 0.99. Explain what the correlation coefficient indicates about the linear fit. It shows a strong positive, in fact, very strong, 99%, strong positive correlation between the height and weight of ponies and horses. And that's enough. I think that's all what you need to do. Okay. And that concludes, I think, part 4. I think we did 4 problems, right? Yeah, part 4. I'm sorry, part 3. Part 4 is 6 credits. It's only one problem. It says Dana went to shopping for plants to put in her garden. She bought 3 roses and 2 daisies for $31.88. Later that day, she went back and bought 2 roses and 1 daisy for $18.92. If R represents the cost of roses, R for roses, and D represent the cost for 1 daisy, so D for daisies, write a system of equations that models this situation. That's a very simple thing. They give you you said 3 roses, so the cost of 1 rose is R, so the cost of 3 roses would be 3R. The cost of a daisy is D, so the cost of 2 daisies is 2D. And this cost was $31.88. Then later she went back. So the second equation, she bought 2 roses and 1 daisy for $18.92. And here are the 2 equations. Very simple. You are simply writing back what they gave you. Use your system of equations to algebraically determine both the cost of 1 rose. So what is R, what is D? I usually don't like substitution. I mean, you can, but I prefer always to use elimination in these types of problems. And I look for any variable, either the R or the D, if I have the same multiplier, the same coefficient, like D and D, or R and R, or R and negative R, or D and negative D. I don't have that case. So I can get rid of the R or the D. It seems that getting rid of the D is easier. Someone would ask why. Why do you prefer to get rid of the D first? Yeah, because here I can multiply the lower equation by -2 and add it to the top. But if I want to get rid of the R, I would multiply, say, the top by 2 and the bottom by -3, or the top by -2 and the bottom by 3. So I have to do 2 operations instead of 1. So if I call this equation 1, that's what I like to do. And the second 2, I can say equation 1 minus 2 times equation 2. So I see what I'm doing. So I will say 3R. So this equation would be 3R minus 4R, right? Because I'm multiplying the bottom by -2. 1 minus -2 times 2. 2 times the second equation. So 3. So I can say 3 minus 2 times 2R plus 2D minus 2 times D equals 3188 minus 2 times 1892. Now, 2D minus 2D cancel, and you get 3 minus 4 is -1. So this becomes -R equals. This is 3188. You can use the calculator, of course, minus 3784. So that becomes 596, -596. Right? If I want to do it with a calculator, I'm going to say 3188 minus 2 times 1892, -596. So -R equals that. So you just multiply by -1 and you get R equals $5.96. That's the rose. No, I will send you to a much cheaper shop. Okay, now I can take this and substitute it either on the top or the bottom. So I can say substitute in either 1 or 2. Substitute, say, in 2, since 2 has D by itself, I won't be dividing by 2 at the end, right? Instead of solving for 2D and then divide, I'm going to say substitute in 2. So 2 times 596 plus D equals 1892. Wow. It turns out when you multiply that, you get 1192 plus D equals 1892. And then I'm going to subtract 1192 from both sides. And you can see that D equals 7. So D equals $7. Usually, to make sure I didn't mess up the numbers, I'm going to take the 596. So 596 times 3 plus 2 times 7. I got 3188. So I checked my solution. Okay, I can do the second, but I use the second to solve, so it doesn't make sense to say like 1192 plus 7 is 1890. I already know that. Okay, so that's the second part. Oh, we only have three parts. Yeah. If Dana had waited until the plants were on sale, she would have paid only $4.50 for each rose. So R equals $4.50 and D equals $6.50. So instead of $5.96, she would pay $4.50, and instead of 7, she gets a 50-cent. Determine the total amount of money she would have saved by buying all of her flowers during the sale. So you can say Dana bought, in the beginning, she bought 3 roses, and then she came back and bought 2 roses. So she bought 5 roses. Also, the first trip, she bought 2 daisies, and then 1 and 3 daisies. Okay. Now, total price for after saving would be 5 times 450 plus 3 times 650 equals. This is 2250 and this is 1950. So that's $42 even. They didn't ask you how much. They said how much she would have saved if she had waited until the sale. Now, so Dana saved. What did she pay? She paid on her first trip $31.88, and on her second trip $18.92. And if she had waited, she would have paid only 42. Wait a second. Yeah, 42. So how much did she save? And we will use the calculator and say 31.88 plus 18.92 minus 42 equals $8.80. And that's basically the answer. Would have saved. She didn't save. Would have saved. Okay, so pretty straightforward. It's linear equation. You just understand the meaning. And by the way, this is the way you should, if they didn't give you this piece, I've seen people, a lot of students would say, let R be rose and D be daisies. What does that mean? R is a rose? No. R would be the cost of one rose. Because if you tell me roses, is it the number? Is it the cost? It's what? You have to be very specific in math. So when I say it's the cost of one rose, and you say I bought 3 roses, then I paid 3 times the cost of one rose, which is R. So it's 3R. But if I don't specify it, I may get confused at the bottom, and I say, what? R is 3, is that the answer? Because they ask me what is R? Solve for R and D. And if it's the number, then I would say, oh, she bought 3 and then 2, so R is 5 and D is 3. No, it's not. So please be specific if you were to write the meaning of the variables you are using. So D represent the cost of one daisy. They never said represent daisies. It wouldn't make any sense, right? And I wrote daisies instead of daisies. I don't know how did I do that, but okay. Okay, so that concludes the test, and I hope you got it all. You would nail it down, as we say. If you have any questions, please let me know. If you want me to solve another test, I will be able to. I would like to do that. If not, then maybe you want a specific topic that from the topics we covered that you didn't really get well understood. If you want me to go over that, that's fine with me. Otherwise, I wish you all the best. And yeah, I want you to nail it in the test. Thanks and have a great day.